Okay, so we are back with more identifying ordered pairs that satisfy the function. The good news is that some of these are going to be easier, and some of these may not be quite as easy. So we will see what happens to us here. So the first thing on these with the graph, one of the things we want to do is make sure to uh, check and see if we can test the point on the graph. And so for like point A here, let me change colors really quick so we can see it against the black. 1, 0 is right there, and that is obviously not on the line. So A is not going to be a solution. B, 4, -2 is right there, and that is on the line. So B does satisfy the function. C is -12, 2, and we can't see that on the graph. We're going to have to do something else for that. And 3, 8. So 3, 8 is way up here. That's point D. That is obviously not on the line, so that's not going to happen. Let's take a look at -12, 2, though. What we need to do to test -12, 2 is go ahead and make an equation for this line so we can see that the slope of this line, the line is going down 1 and to the right 1, 2, 3, 4. So our slope is -1/4. And we can see that our y-intercept is -1. So if we go ahead and write the equation for this, we would have y equals -1/4 x minus 1. And so we can put those points in there just like we have all the other ones, and we will have 2 is equal to -1/4 times -12 minus 1. I don't think that this is going to work, but we will see. So 2 is equal to +12/4. Oh, I might be wrong. Minus 1. 2 is equal to 3 minus 1. And yep, 2 is equal to 2. So C also satisfies the function. So again, a couple ways to do these ones, folks. We can do see if it's on the graph or not. And if it's not on the graph, write an equation for the function and then test our point using the equation. So on to number 2. We have -2, 0, and that's -2, 0 right there. So yep, -2, 0 satisfies the function. An announcement coming on. Let's pause that. Okay, the announcement is over. So let's go ahead and test the point 4, 0. So 4, 0 is going to be right here. And that is not on the line, obviously. -6, -5 is next. -6, -5 is right there. And that is not on the line, so nope. And 3, 10 is not on the graph. You might be able to extend the graph and see if it's going to land there, but I'm going to go ahead and do the equation like we did on the other one. And so we can see that our slope is 1, 2, 3, 4 up and over 2. So our slope is 4/2. Or 2. And our y-intercept is 4. So an equation for this one would be y equals 2x plus 4. So we got to test those points, the points 3 and 10. So 10 is equal to 2 times 3 plus 4. 10 is equal to 6 plus 4. 10 is equal to 10. And so yes, D does satisfy the function. I'll leave this here and pause for a moment in case people need notes or to talk through it. And I'll move down to number 3 and 4. Okay, so for slope here, we are going down by 6, down by 6, down by 6, and down by 6. And over here, we are going up by 3, up by 3, by 3, and by 3. So our slope is negative 6 over 3, or negative 2. And our y-intercept, it looks like, is negative 14. We can see that from the last row of the table there. So as we have done on the previous worksheet, and I hope I don't run out of room here, so what we've got is y equals negative 2x minus 14. And so we'll test point A, and we'll check actually first and see if any of these points are on the table already. It looks like negative 2, negative 6 is not there. Negative 3, negative 8 is there. So B is a solution. Negative 4, negative 6 is not there. And 6, negative 26 is not there. So we only have to test A, C, and D. So let's test A. Our y value is 10. Negative 2 times negative 12 minus 14 is what we've got to try. And so 10 is equal to 24 minus 14. And yes, 10 equals 10. So A satisfies this function. We already know B does because we see it in the table. C, y equals negative 2x minus 14. So negative 6 equals negative 2 times negative 4 minus 14. So we get negative 6 is equal to negative 8 minus 14. This one's not going to work. Negative 6 is equal to negative 32. So not going to work. And another way we could also know, and this is just kind of a little trick, since we already had negative 6 right here and that worked, for this to be a function, negative 6 can only have one other partner. We already know it works with negative 2, so it can't work with negative 4. Another way to kind of catch it if you are paying attention to that. So D, we have y equals negative 2x minus 14. So negative 26 equals negative 2 times 6 minus 14. I think this one's going to work. Negative 26 is equal to negative 12 minus 14. And yes, negative 26 is equal to negative 26. So for D, that does satisfy the function as well. Alrighty, I'm going to pause there, and then move on to number 4. So for number 4, here we are decreasing by 4, by 4, by 4, and by 4. And here we are decreasing by 2. So slope, negative 4 over 2, over negative 2, or 2. And for this one, to get our y-intercept, we could just count backwards. It looks like we are going to land on 0. So I've got to go down 2 to get to negative 6. Down, no. Yeah, I've got to go up 2, my bad, to get to negative 6. Up 2 to get to negative 4. Up 2 to get to negative 2. And up 2 to get to 0. So same number of steps on the right. We've got to go the opposite of going down by 4 is going up by 4. So this is going to be 8. Next one's going to be 12. Next one's going to be 16. And the next one's going to be 20. So I'm just going to put some lines really quick to make sure that I got the same number of steps there. So there's a step, there's a step, there's a step, there's a step. So yep, our y-intercept is 20. So for our equation, we are going to have y equals 2x plus 20. And we can look through the table and see if there, or through these values, and see if there's anything that already matches. And I can see that I have 0, 20 in my table, so 0, negative 10 is not going to work. I do have negative 12, negative 4 already in the table, so that one's going to work. Negative 12, negative 16. Negative 12 is already with negative 4, so it can't also be with negative 16. And 0, 20 is in my table. So we were able to test all of these using the table. We don't have to do any work with the testing them on the equation over there. If you wanted to test them with the equation, you could. Nothing wrong with that. But we were crafty and able to just tell by looking at the table. Okay, that's going to be it for number 1 here. I'll leave this kind of zoomed in for notes and things if people need that. That's it for this video. We'll be back with the next.